Right, so this is a rain and lightning task, or tasks, as there's 4 parts. So let's start with part 1. Today there's a 55% chance of rain, a 20% chance of lightning, and a 15% chance of rain and lightning and rain together. Are the two events, rain today and lightning today, independent events? Justify. So the formula is, so we have here, this is P probability of A. Now this, the lightning, is probability of B. And 50% of chance of lightning and rain together is a probability of A and B. So knowing that, there's a formula where the probability, if the probability of B given A is equal to the probability of B, then the two events are independent. If they're not, then they must be dependent. So knowing that, let's calculate. So the formula to find out the probability of B given A is equal to the probability of A and B over the probability of A. Then we plug in our numbers. So then we know that the probability of A and B is 15%. And then the probability of A is 55%. So then the probability of B given A is equal to 15 over 55. This can be simplified to 3 over 11. So this is the probability of B given A. So is 3/11 congruent to the probability of B? Well, the probability of B is 20%. But so 3/11 is not equal to 1/5, which is 20%. So that means our events are not independent and actually dependent. Now for part 2. Now suppose that today there's a 60% chance of rain, a 15% chance of lightning, and a 20% chance of lightning if it rains. What's the chance of both rain and lightning today? So again, we have our probability of A, which is rain, our probability of B, which is lightning, and the probability of B, lightning, given rain, A, which is rain. So probability of B given A. So now we're trying to find what's the chance of both rain and lightning. So the probability of A and B. Well, we can apply the same formula as before. This time we have different numbers. So the formula is probability of B given A is equal to the probability of A and B over probability of A. Now let's plug in what we know. We know the probability of B given A is 20%. And we know that the probability of A is 60%. Now we're trying to find X, which is probability of A and B. So 20%. So then if we cross multiply, we get we know that 20% is equal to 1/5. Which is, so what over 60 is equal to 1/5? Well, that's 12. As 60 divided by 60 divided by 12 is equal to 5. So then our answer we get the answer of 12%. Another way we could have gotten this is by cross multiplying. We do 60 times 20. This will go 20 over 1. So we do 60 times 20. We get 1200%. 1200 is equal to X. But we actually get rid of these extra zeros, as we have to divide by 100. There's 2%. So we get 12%. Now for part 3. Now suppose that today there's a 55% chance of rain, a 20% chance of lightning, and a 15% chance of lightning and rain. What's the chance that we will have lightning or rain today? This or is a key big difference. So so now we have a broader scope as we can have either rain or lightning. So now here we have to add 55% and 20% as these two will increase. So 55 plus 20 is equal to 75%. So now we have a 75% chance of rain or lightning today as we add these two since either one of them could happen. 5%. Now for part 4. Now suppose that today there's a 50% chance of rain and a 60% chance of rain or lightning and a 15% chance of rain and lightning. What's the chance that we will have lightning today? Well, it says here that there's a 60% chance of rain or lightning. As I said, in order to get this, last time we added the chance of rain plus the chance of lightning to get the chance of rain or lightning. Now we do the same thing, except the equation is a little bit different. So we have lightning plus the chance of rain, which is 50, is equal to the chance of rain or lightning, which is 60. Now we just subtract 50 from both sides to get x as 10. So now the chance of lightning the chance that we'll have lightning today is 10%. So there you have it. The answer part 1 is dependent, part 2 is 12%, part 3 is 75%, and part 4 is 10%.